Alright, I am back. And we are working on exercise 2 of chapter 12. We talked a little bit about how to approach this one. And I don't really know Zig too well. So I feel like maybe I should implement this in C instead of like continuing to mess around with Zig. Because there's a lot of things in Zig that like, I'm not familiar with. So I'm happy to go back to C. So let's do 12.2 exercise. Let's see. Just go to main here, and this would be include. Oops. Standard io.h standard lib, and then so we have to list proc or let's just very high level do this, like find all PIDs, read PIDs ppid every PIDs ppid plus command name, and then store in some data structure, and then once that's done, then we can output or print out the data structure. As a tree. So that's like the super high level thing I'm thinking of here. Write a program that draws a tree showing a hierarchical parent-child relationship of all processes on the system, going all the way back to init. For each process, for each process, the program should display the process ID of the command being executed and the command being executed. The output of the program should be similar to that of PS tree, although it's not to be sophisticated. The parent of each process on the system can be found by inspecting ppid line of the status files on the system. Be careful to handle the possibility that a parent's process parent, and thus its procpid directory disappears during the scan of all procpid directories. Okay. So getting all the PIDs, I'm going to redesign this this is conceptually like what I want to do, but I'm going to redesign this so it's going to be more iterate through the listing of proc if dir and name is numeric, then we read the status file for PID, that PID store ppid and name in some data structure. And then print out the data structure. I think that's more of what I was thinking. So there's read dir. Oops. Let's go ahead and go man3 read dir, because I don't think there's a syscall for reading dirs. readdir function returns a pointer to a dirent structure representing the next directory entry in the directory stream pointed to by dir p. I wonder if there's syscalls that I could use. I don't like using these high-level things. What syscall on Linux is used to list a directory? Because I think you're just reading from the directory. Open directory like a file, and then get dents or get dents 64 read directory entries. This is the actual syscall return directory entries. I wonder if you just do a read on it, would that man read to directory? Oh, okay, so you can't read on a directory. It gives you back error is dir. So there's man to get dents. These are not the POSIX interface you're interested in. Look at readdir 3 for POSIX conforming C library interface. This page documents the bare kernel system call interface. So if I do ls, strace C on ls of proc. So these are all the syscalls that are being made. Read write is get dent 64. I don't like these high level C library functions because they just obscure so much of what is actually going on when you're talking to the kernel. So it's get dents 64. There's no wrapper for get dents. You give it I like how it says these are not the interfaces you're interested in. That's very presumptuous. GetDunce, a system called getDunce reads several Linux dirent structures from the directory referring to the open file descriptor fd into the buffer pointed to by dir p. The argument count specifies the size of that buffer. The Linux dirent structure is declared as follows: inode number, not an offset, see below. Reclen, length of this Linux dirent, char name, file name null terminated. Length is actually dir reclen -2 minus offset of struct Linux decend. Okay. And then commented out padding and D type. dIno is the inode number. doff is a file system specific value with no specific meaning to user space, though on older file systems it used to be the distance from the start of the directory to the start of the next dirent. See read dir 3. dreclen is the size of this entire Linux dirent. dname is a null terminated file name. dtype is a byte at the end of the structure that indicates the file type. It contains one of the following values: a block device, character device, directory. It should be directory, right? Oh, because the entry could be any type. Yeah. Get.64. The original Linux decadence system call did not handle large file systems and large file offsets. Consequently, Linux 2.4 added get.64 with wider types for the D, INO, and D off fields. In addition, get.64 supports an explicit D type field. Oops. The get.64 system call is like getDense, except that its second argument is a pointer to the buffer containing structure of the following type. These calls supersede readdir too. Oh, there's a readdir. Man to readdir. Oh, interesting. Man syscalls readdir. Get dense. Old Linux direct structure from a directory referred to by file descriptor fd to the buffer pointed to by dirp. So do you just keep on calling the syscall like multiple times? And it gives you, it writes in a, oh no, it's an array. Derp. So I'm gonna do that S trace. I'm gonna do, what is it, E? Or do C first, and then, what is it, E? What is it, get dense 64? So it did the initial. How do you know how many entries it wrote? 587. Where's that even? Yeah, I don't get that. It says here, okay, this is a pointer to the buffer. You give the length of the buffer and the file descriptor. We made two calls. The first call said, hey, I gave you 15,744 bytes. And somehow it's like, oh, there's 590 entries. So if we did 15,744 divided by 590, it's not even an even division. So maybe it like goes through each record, I don't know, man, and adds up the length of everything, because the lengths are pretty variable because of the char star. Is it a char star? I mean, it's effectively a char star. I don't think that's going to be an array, because we don't know the size. So it's going to be a pointer to somewhere else in the buffer. Okay, let's go to readdir, since everyone's saying man3 readdir is the way to go here. The readdir function returns a pointer to the dirent structure representing the next directory entry in the directory stream pointed to by dirp. It returns null on reaching. So you give it a dirp. We're already in libc file IO land. So basically the same exact structure. And there's no reentrant version. It's statically allocated. I don't like this, man. I'd rather hand it the buffer. and make the syscall myself. Oh, this is why you need to have those offsets, yeah. Okay, that makes sense. So the first thing is to do an open on the file. So we do open on proc. We give it the read only, and we give it O directory. And then we get back our int fd, and then if fd is less than 0, we then p-error on open of proc and return exit failure. It's going to be fcntl.h. Oops, need a semicolon here. Okay, we got a directory. Now we gotta allocate a char buffer. I'm gonna do 32. What is Python -c? There's just 2 to the power of 10 to the power of, what is that? 18? No, it'd be 8 plus, yeah, it'd be 8 plus 10 would be, yeah. So I want 2, 4, 8, 16, 13, I want 5, so it'd be 15 there. How do I represent that in C? I think it's 2 or 1 bit shift over by 15. That, yeah. So that's my buffer size. And then number of elements I've read, which I'll knit to 0. And I guess I don't need to knit that to 0. And I don't need to knit this to 0 either because of my loop. So while I'm going to read, and this is going to be man. I don't have to use, I use the wrapper man to get dense 64. So here I say get dense 64. The file descriptor is the first thing, and then a pointer to my buffer. I guess I don't need to point to it because it's an array. It gets passed by reference. And then the size of buffer. We say, hey, if that is all, while that is greater than 0, then we're going to buffer position 0. Then we're gonna get our while the buffer position is less than number red, then we read our record. Say struct linux dir int 64 pointer to d is equal to the buffer plus the buffer position, and we're gonna make that to struct linux dir and 64 pointer, and then printf, %s new line, oops, d reference d name bpos plus equals d underscore record length. Why is that? D rec length unsigned short. Huh. Oops, sorry. So we take the buffer, we add the position, which would be 0. We assert that, or we cast that into our struct pointer, and then we assign it into D. That seems right to me. It says incomplete definition of type struct. Oh, because I don't have the actual struct defined anywhere. So if I go here, it's probably gonna be include syscall. Okay, oops. Oops. That was not it. So I don't think I'll need that. That's for calling this syscall manually. Durant.h, that's the one. Why is that? Come on. There it goes. Call to undeclared function. I have to define this GNU source thing. All right. Incomplete definition of struct. What are you talking about? This thing's totally defined. Maybe I gotta do the syscall in this thing. Maybe it's this thing, yeah. Oh, so annoying. Nope. I never had this happen before. So the dirent here. So I don't need the syscall because that's just for the thing there. Dirent. What do these guys use here? Because they have the dirent structure. Just gonna grab all these. Oops. Linux dirent.h. I think it's just called dirent. Yeah, Linux dirent. Yeah, dirent.h. Can I go to here? Yeah, there is no Linux dirent. guess we define it ourselves. Alright, there we go. Let's try to make this stuff. Alright, make jump chapter 12. Make build 12.2. Okay, that looks like it worked. Now we just need to filter for numeric. What are these here? You know what I'm gonna do? I'm gonna run this thing and say, hey, sort, or just pipe it into temp A, and then ls dash, or just ls on proc, pipe that into temp B, vim that up. Oops. ls, can I do a basic ls? There we go. And then I can do delta on temp A and B. Of course, they're massively different. Wow, there's like control characters and stuff in that one. Can we do a, it's a call or calls? Oh, what is it called? What is the Unix util that will show you two sets of lines and give you the columns of what is the same and what is different? Com? Yeah, com. Input is not in sorted order, okay. Sort temp A and sort temp B. I rarely use this com. Compare two sorted files line by line. I do delta now, delta between temp. No. So sort temp. What is the control D? Oh, those are the bytes, right? What is that byte? The reclen is the total length, which is useful for this, but not for printing out D name. It says file name is null terminated. Huh. EOT, what is all this stuff? Let's see. Okay, if we look at this, we got 2e, which hex would be not in the printable range. Alright, we got 2e here, which is period. Great. And then 04 EOT. 04 end of transmission. And then a new line. Can I just do A? D-type, that's what I was thinking. Okay, so I need the 64-bit. Even though it doesn't say that, I don't think in the man page for get dense 64. It says here's the Linux dirent, and then it says get dense. Oh. Yep. Totally missed that. That would be why. So I got inode. Totally different size, yeah. Says buffer then needs to be read into dirent 64. Dirent 64, that's why. Inode off, recline type in name, so I'm interpreting the type, yeah. Alright, cool. Make And oops, there we go. Now we do our delta. Hey, look at that. And I'll redo my ls too. Into there. Very similar. So I guess the difference is ls has this proc ls. Yeah, they have the thing that removes the which isn't that weird? Type ls? Oh, because it's an alias, that's why. And I removed the alias. But even this ls, oh, because I'm not doing dash a, okay. So if I do ls dash a, then it'll give it to me, yeah. So if I go here, ls dash a proc into temp-e, and then temp a gets the result of running that, and then I do a delta. Oh, I need to do a sorted delta. Yeah. Okay. So now we need to test the numeracy. So we just say bool is numeric char star stir, and here we just say while int cursor is equal to 0. While, oops, cursor is, sorry, while stir subcursor is not equal to 0, we say, hey, is, let's say bool ret is equal to false, return ret if, go back to our ASCII table here, we're going to say if the, so 9, yeah, makes sense. So let's say if this is greater than 9, or this is less than 0, then we're outside of the range, and we can just say return false, return true here, delete that, And then here we say cur plus equals 1. I think I can do plus plus. Let's see. Need to include bool.h, I think it is. Standard bool. There we go. Whatever. Okay. I could also, I don't need the numeric value of the PID though, so I'll just leave it as a string. So in here we're gonna say, okay, I'm not gonna print it out yet, and we will increment here. So now what I want to do with the struct, I want to read its, put this in here. If dir name is numeric, so we have this is numeric of the name. Or we say not. If it's not numeric, then we just continue. Now we need to open. Someone's bugging me on my phone here. Proc plus dname plus status. This will be status fd int. Give it O read only. I don't like having that. Let's do that. O read only. It should be good. This is erroring out because of some reason. Invalid operands to binary. Oh, because it's you need to do some type of f print or s print f. Man 3 s print f. Proc %s status. Some programs imprudently rely on code such as the following bugs. So you give the buffer, you give the size, and then you give the format string and the arguments. Okay. So I want to do s n printf, the buffer and the size, format, and the d name. The buffer will be status path, and this would be a char array of 1024. Can't possibly be that long. And then here I'm going to pass the status path along with size of status path. And then what's the return value of this? I don't really care what the return. So this open now becomes the status path. Now we get to read it's not what I wanted. Not what I wanted. There we go. There we go. That's interesting. Fast. C code to read in the contents of a file into memory. So the memory could be stack allocated. All right. We got a stack allocated buffer. Read into it. The problem is that it could be a partial read. And stitching it from like the last line, like the line the lines could get partially red. So I'm gonna just do some, well, I want to read this file into memory. Let's create a new thing here, and what I want to do is just say ls on proc and xargs, oops, or while, we'll say while read line do echo $1 line done. Okay, so this needs to be slash like that, and then we could say, well, read line do if a dollar line is a file, echo dollar line done, vi done. Oops. I would have thought that's correct. Save text. Oh. Then. There we go. Man test file. D. Proc. Yeah, I want D. Have these reversed. I want it like that. Bash. Oh, because I didn't escape this fucking thing. Alright, that makes sense. There we go. So there's no directories there? Oh, we have to do test d slash proc line like that. Okay. I think what I'm gonna do is say, hey, test to see if there's a file in status. What's that thread safe thing? Well, regardless, these are all the status. I think I could have gotten these easier if I did like ls proc ** status. Yeah, it's a lot easier. And then here I can just say like word count, xargs, word count, C. And some of them are going to go away as they're being ran. Why does it have a total there? I don't like this xargs thing. We'll do while read line do $line done. And then we're going to send 2 to dev null. And then we're going to pipe this into awk and grab the print $1. Grab the first field. And I'm going to say how do you say oh, that's good. Use like sort dash n, that's a good idea. Sort dash n. And then, so 1570 is the largest one. Okay, here's where it's using the basic system calls is like starting to cut against me. I think there's a get PPID. Man get PPID 2. Sorry. No. Yeah. I'm just gonna call this thing. Make it a lot easier. So yeah, I don't have to do any of this allocation here. I do have to convert it to the numeric value though. What I'll do is say, instead of is numeric, we'll say 2. And there's a library function for that too. It's man ASCII to integer, A2I. So we'll just say int PID is equal to A2I of the D name. That's assuming if it's not is numeric D name. Continue. I don't like that. Okay. So we check to see if it's numeric. If it is, we convert it to our PID. And then we just make the syscall for man to get PPID. And we say PID-T PPID is equal to get PPID of oh no, that's if okay, is there a Linux syscall to get the parent PID of an arbitrary PID? Proc where's 2? Using libproc or procfs libraries. Okay, you have to read this. Let me back out of that change then. Okay. I'm just gonna assume the size. So this will be char, and we'll call it status buff. Buff is an array, and we'll say 1 bit shift over 10, 11 would be 2, 12 would be 4. Let's say 12. And then in here, we then do a read of, let's do man to read. We read the FD, which is SFD. And I'll do a code rename on this to be status FD. So read the status FD into the status buff, and we'll give it size of status buff, and we say if the read is less than 0, then PR on read and return exit failure. So now we gotta like scan through this file. So cat out, say like proc self status, and we want the PPID, which is here, and I'm gonna pipe that into octal x a. Then we go up the top here. Tracer PID. It was after tracer PID, right? Right before tracer PID. Tracer PID. Here it is. PPID. So we have the string PPID and then a tab, :tab, and then 62654 to new line. So that's what we're looking for. That's the pattern. So it's gonna go like that, basically. So we say while, I'm just gonna while out. Well, true. Actually, you know what? We're gonna say for int I is equal to 0, I is less than size of status buff, and then I plus plus. We could do a little state machine where we progress, say, hey, we got a new line, we got a P, we got P, we got an I, we got D, we got a horizontal thing. And once we get that whole token, then we start reading to the new line, numeric characters. Sure, let's do an enum. States. And here we'll have like end of EOL, and then we'll say P, PP, and then PPI, oops, and then PPID, and then PPID colon, and then PPID colon thread or tab. Okay, and I need commas here, right? So we're going to switch on these states, and we're going to have different cases here. Case, we got to start at unknown, and then here we'll have a states, state is equal to unknown. And we're going to switch on state. And if we're in unknown, then we say, hey, if oops, break, if the status buff of I is equal to the character new line, then we progress to state is now state is now equal to EOL. Otherwise, we stay as unknown. Then we have a case where we are EOL. And then we'll do a similar check here where we say, hey, if the status buff at I is now at a P, right? This next one. Then our state is going to be P. Otherwise, if it's not, then we go back to unknown. So we say else, we go back to unknown. What could be else if we can go back to EOL. So we are at new line, so you get two new lines in series, one right after the other. So if we're at new line, our next thing is P, then we progress, or it could be N, where we stay the same, or we go back to the beginning, which would be unknown. And then I'm gonna grab all of this stuff and just call this function get PPID. And this is gonna return a int get PPID. So I think that's a good use of a function. I'll put it up here, so it's forward declared. The get PPID, we're going to give it the status buff and the size of status buff, and it's going to return to us the integer PPID if, and then we can handle the case where PPID is less than 0. Then we'll just continue. Less than 1, really. Continue. All right. Delete that. We don't need that. I'll go back up here. Okay. I'd say states.unknown, like that. Must use enum tag to refer to type states. I should say, why is this incorrect? I have to say the full enum. There we go. Okay. All right. And here we need to get the buff, which will be status buff, which is a char star. And we have our size t, I guess, of, what is size of return? Return size t, right? Where is it? Here. Let's do size t. We'll just call it size. Status size. And then this will be status size. 6 enumeration not handled. Yeah, we're getting there. Okay, so now we go to case P. We'll have something similar to this, where we say, hey, if your thing is P again, then we're on the second P, and we can say state is P. Else, if it's a new line, we can go to end of line. Else, it's unknown. Next one will be case PP. Oops. Fix that. And if the buffer here is I, then we go to PPI. These are all the same. Case PPI. And then if this is D, then PPI D. Then here PPI D. If this is a colon, oops, colon, PPI D C. And then case PPI DC. Oops. Then this will be a /t. Then we go to PPIDCT. Oh, gotta break out of here. Yeah. Then our state is here. So then we do one more loop around. I don't think we need to, well, we'll say, hey, if your case is here, T, then we just continue or break. We want to break A to I of, and I needs to be, we're just trying to find I. So we want to initialize that out here, so it's preserved. But we could keep it inside here and just return. It's like, hey, we're at the I where the number starts, so we say A2I, and we give it the status buff plus I, and we return that. Oh, there we go. Okay. So we can say print, here we can say printf. Oops. I'm gonna do my PID, then the parent PID. My PID is a string though. Parent PID and the name. What's the name again? D name is the parent PID. Okay. Let's look here. PID. Okay. And this will be PPID. Make. I think I need the Unix standard.h. Okay. Oh, there's also the other thing I wanted to read out, which is the name. We'll do the same thing here. A similar thing here, get name. Char. Oh no, this needs to be int. N, N-A, N-A-M, N-A-M-E, N-A-M-E, colon, and then I need to pipe this into odd. So it's N-A-M-E colon tab. These. Okay. Unknown. N. N. A. Just gonna delete all these because just copy it from here, be easier. So if we're already at N and the next one is A, then we go to NA. else, go back to unknown. Oh, it could be n though. That could be n. No. I need this EOL here. EOL. And I'm just gonna start on EOL. So here, we need a few things to seed this. So go down here, paste them. So unknown. So we'll be EOL to start. But if I'm ever at unknown, I need to get back to EOL. So that's what I'm trying to do here. And then we're in EOL. Okay. Then if we're N, then we go to N. Otherwise, we go back to EOL or unknown. If we're at N and we have a, then we go to NA. Otherwise, same thing. If we're at NA, oops, go away. M, go to NAM. If we're at NAM and we get a E, we get NAME. E colon C. NAM C T. And then the final one we just handle on our own. So here we read until we hit the new line, but we need to write it to the output buffer. So that's a mem copy. Man mem copy. Sorry, CPY. Why does it do that? That's annoying. Destination, source, size. So our destination, let's say mem copy. Destination will be name buffer. This source would be status buffer plus I, and then the length will be the minimum of either status size minus I or name size, whatever is a minimum. So is there a min function? I don't think there's a min function. Let's see. It's min macro. Let's try that. And then we probably have to define that by going up here, going and importing sysparam_h. Sysparam_h. Okay, that goes back to copy, and then that gives us back a void star. I don't need that because destination should already have it in there. There's no null byte terminating it though, it's a new line that terminates it. So what we really need to do is throw away this thing and find out length. So we don't need that. So in here, for int j is equal to I, j is less than status size, j plus plus. So we're going to loop over this until we see int if the status buff sub j is equal to new line, then we say break and we pull int j out. Int j is equal to I. This would be up to j, or up to j, yeah. Or j minus I. Printf percent s new line name buff this will be a return j minus I, something like that, right? Label followed by a declaration. Mem copies in string.h. Please go away. Alright, that fixes that. Alright, so what is this complaining again? Conflicting types. Get PPID. Yeah. Oh, this is get name. Okay. We read everything into the buffer, and then we get the PID, and then we say get name here, but we have to allocate a buffer. Let's say char 1 to the power of 10. Name buff here, name buff and size of name buff, and then this would just say if is less than 0. Continue. And this will be get name, not get PID. Bam. Can I break these into lines here? Okay. That seems silly. Whatever. Continue. We have to insert a null character at the end. So we do the mem copy and then name buff at j minus I is going to be equal to 0. What is all this K-worker stuff? Yeah, that is end IO right. Okay, so we have all the data. Now we have to insert it into a data structure. And so we have our data we need to insert into data structure. And what I was thinking is having it be a map of int to a array of, or a resizable array of slice of int. But this needs to be a struct of PID, which would be int, and What else? The name? Yeah. Oh no. I think it needs to be like this. So map to struct of the name, which would be a char star and slice events basically. And because the D name is already a string, we can make this a char star. And then the get PPID means that we can make that a char star too. Because this thing, char star PPID buff and size T PPID size, and then we'll do the same kind of mem copy thing here. And we'll need to declare J here, up here. Copy into PPID buff, status buff plus I, this will be okay. Down here, we'll now need to allocate wonder if these buffers that are declared inside of a loop are reused. And see if you declare a buffer inside of a loop body, does each iteration of the loop reuse the buffer memory? Okay, so I need to copy these out. Because these buffers are just like... they're gonna go away as soon as this loop ends. What is D? D's definitely going away. Yeah, it gets reassigned here. Map of string to struct of string and array of string. I've heard of glib. STB instead of STD. Glib. So it's available. I think I'll go with this one. But yeah, I'm gonna take a quick break here. Be right back.
All right. So, I think I want to ask Gemini. I am new to C programming. I want two data structures. One, a hash map. Two, a resizable array type. What is the most popular library to acquire these data structures? Popular open source library. When developing software on Linux. glib. Seems like everyone likes this glib. Hash map. Of any pointer type. Resizable array called garray for structures, or gptr array for lists of pointers. UTH hash, STPDS, the easy header only choices. If you find glib too heavy or bloated for a small project, header only libraries are popular because you don't have to deal with complex linking. You just pound include a file. UT hash, specifically for hash maps, you add a simple structure member to your existing struct and it becomes a hash table via macros. STPDS, a single C header that provides both hash maps and type-space dynamic arrays. It's highly regarded for its simplicity. From a library that feels more like traditional data structure libraries similar to Java's collections or C++ STL. Collection C is a modern, clean choice. Hash maps. Why use it? It is designed to be generic and consistent, making it very easy for beginners to learn compared to macro-heavy syntax other C libraries. STPDS. Oops. Interesting. So you create an array by just saying, hey, I want an integer pointer. And then you say array put. And because it's probably updating that pointer to point to new places in memory. Allocating on the heap and updating that pointer. And then how do you free things? Yeah, there's AAR free the entire array. It's a pretty nice API. I mean, it's macro driven, so it's going to be like super like magical. But conceptually, I think it's reasonable. Yeah. Yep. Same thing as in Go with slices. Here's string hash maps. Oops. I think it might be easier just to convert these things to integers. So here, this would be our hash. We'll declare it up here. Oops. Our int key, and then the value will be a struct of type what was it, name? Name and children, or yeah, children. Children will be a pointer to an integer. Name will be a char star. So that'll be the type of the value. So we say struct value. Value v k. Sorry, struct value. That. Cool. Okay, so we have that declared. Okay, PPID, so we can say A2I of PPID buff will now be int PPID. If PPID is less than 1, then we'll just like There we go. Do the same thing down here. Now for the name, it would be the PID, which is the D name. Okay. So you have PID, PPID, and name. Delete this thing. We're going to put into the PPID, say, hey, your parent. First I got to get the structure, modify it, and then write it. Because it might be null. It's kind of annoying. C is pretty annoying. Alright, I'm just going to use AI to help me with this. I should be able to do this by myself. Okay. Before I put anything, I need to read it. So I can just index into it? Really? Here it goes. Get the corresponding value corresponding, yeah, HM get. In addition, structures can contain multiple value fields. The only requirement here is that there is a key field. To do this, you must use structure values explicitly. So we have this struct as a key and multiple values. Oh, interesting. So I don't have to make a struct there. That's interesting. Let's try doing that. So we say our struct hash up here. We'll do a type def of the struct and call it hash or PID hash. We'll call it a PID hash. And then in here we have our key, and then char star and children. then here, so it's heap allocating all this stuff for me. Okay, so now we want to say h puts, and we give it the hash, of course. Oops. And the key. I'm gonna say element, lm, and then we'd say my struct pid hash lm is equal to a pid hash ppid. We'll say k like that. And then dot name. I need to do my reads first. So it's going to be hm gets hash ppid. So this is going to be type hash or pid hash. Or ppid element is equal to that hm gets now that's giving you back the value, which would be not be ppid hash, would it? Maybe. So we get the ppid first, or do we get R's? Let's get R's first. Should be pid element pid, and then here pid element dot name is equal to d name. So I don't think that's going to work because it's not going to be able to track that is. Everything's going to point to the same memory. So we have to make a buffer here, I think. To do make buffer for name on heap. But let's just roll with it for now. The ppid, we can then say ppid lm dot children. So that's going to be an array say r put onto that the value PID.
This is super optimistic. Like I don't think it's gonna work.
What is this? Operands of type void. Here, let's just do that one first. Oh, great. No member of named key in PID hash. Oh, it's K instead of key. There we go. Okay. All right. I don't think this is gonna work, but let's output here. So hash plus here, say hey, here's the key, %d, key, and then name, oops, s, name, and then we'll have to do another one of these here. Value. This will be the children. I'm pretty sure this is gonna like blow up or have incorrect results. Bad ppid a2i. This thing here. Oh, it could be 0, so let's say less than 0. So you can't have 0. And we won't have like a, yeah, it's fine. So call hm gets, get the value corresponding to the key or return the default. So that gives us back some elements. And then we say, hey, here's your name. Actually, before we do that, let's go down here and say printf handling pid %d ppid or name %s ppid %d, and we'll do pid name ppid. The name is d. Oh, that's the wrong thing. Name was name buff. Yeah, here it is. Name buff, not dname. Okay. Hey, looks like I got some more stuff. Need a new line here though. So PID 2 has parent PID of 1 as well? I didn't know that. Does anyone have parent PID of 1? Grep for, oops, ppid 1? Okay, yeah. Okay. So we do our read. We're not going to copy the buffer for the name. We don't care about that yet. We will care about that soon. And then we do a puts into the hash with the PID element. Shouldn't that be sufficient right there? We do hm puts. Update existing structure or add a new one if key isn't present. Hash is a PID hash null. Let's take out this thing. Is it arrow or dot? No, it's arrow key. In C, what is the format specifier for pointers? Is it P? Key, name, children. We'll do a children one instead of doing the pointer. And then here, there's like a length. Up here, arrays length, rlen. Key is 0. How's a key 0? Maybe I need to set the name here. Alright, let's do that. Key, PID, name. Hey, look at that. Alright, let's set the children now. Yeah, see how these are all the same name? That's where I need to do this copy. So I need a sterlen of name buff. Let's do a man sterlen. And here we're gonna malloc. Does sterlen include the null byte? Excluding the null terminating byte. What is the most idiomatic way to copy a string, a null terminated string, idiomatic, from the stack, from a stack buffer into a heap buffer?
stir dupe. Okay, we stir dupe then. Stir dupe of name buff. Boom. There we go. And we need to add the children now. So do the same thing here. Do hey, get the element for the parent peepid. Peepid element children. We're gonna array put onto it the pid. And then we also need to make sure the key is right. For some reason that isn't set. Peepid element key is peepid, and then we puts it into there. That looks wrong because all the children are the same. Very wrong. So what happens here is that we say, hey, in the hash, look it up by peepid because I need to update its children. And so it gives you back this thing. You say, yeah, I'm just going to make sure the key is right. And then we're going to put onto its children the current peepid. It can be a null pointer. And this thing here, the R put, is supposed to allocate memory for this PID. We say, hey, put this thing back. I think what we need to do is copy the children here and say, hey, that should work, shouldn't it? So we have this element, it's completely separate from everything. If we look at the element, it's PID hash, which has the int star. Oops.
Okay. It seems like maybe it's just the outputting of it. Because this is definitely looking right. It's getting added on here. So key 2 has 4, 3, 2, 1. These are all 2 here. So assuming that put's okay, why would this be wrong? You get the array length of the hash I. Oh, because it's a pointer. You have to dereference. No. The pointer is dereferenced by the indexing. Somehow that children's thing is lost. Well, oh, because you're overriding I here. Silly. RJ J hash I children J plus plus children. Oops. J. There we go. That's just the output glitch. 3, 4, 5, 6. Okay, good. And then we delete that. And then we can comment these lines out. And then I'm going to fix this thing up here to just be this, because I don't think I need any of that. Yep, that worked. Okay. So then we want to print it out as a tree. So let me remove these breaks here. Now that we know the data structure is correct.
So we start at 0. Yeah, we should just do that. So we say, comment this out. Okay, and here we're gonna say hash lookup 0. Can I do that? No, I have to do the get. So let's say get hm get, and I have to say it with an S. Get S, get the value corresponding. Yep. Pass in the hash, give it the value 0, and this will be a recursive thing. So this should be a function so that they can call itself. So we'll just say print tree and give it the hash and start it on 0. 0. Wait a minute, the hash. Okay. Let's grab all this stuff. We'll then have like a function up here. Print tree. And we'll start. So this hash will be a, what type is this thing? Forget. PID hash pointer. And index, which would be int, or a PID, I should say, or int PID. And then in here, you say, hey, grab the hash, look at the PID, and then we're going to print it out. So this will give us back element, which is also a PID hash pointer, right? Or is it a PID hash? I think it's just a PID hash. And then in here, we say, hey, element, printf the elements. We also need that indent level, which will be an integer. And down here, we'll just start that at 0. So printf, we'll say the name and the PID. So %s, and then the PID will be %d. And then the indent, we'll need to figure out that. Should be another %s. For now, I'll just do an empty string. This will be lm.name and lm.key. And then we'll range over the children, which will be here. And we'll say, hey, this will be lm children. We're going to range over all of them. We'll change these J's back to I's. I don't know why they do that. And then here, we'll say print tree of the hash. The PID will be
lm dot children sub I, and the indent will be indent plus plus, or plus, I have to pass it in here, so I have to pre-increment, or maybe just indent plus 1 there, because that's going to be multiple times. And then this can just be void. Oh, we need to pull up our pid hash to be above here. That'll solve that. And then let's go. Okay, we got new lines that we need. New line here. Cool. We look at the top here. We should have null at the root. Yeah, and then systemd. Okay, printf here. I'm gonna comment that out. Okay. Print tree. Oops. There we go. Okay. So we need to find out and see how do you create a string that is repeated n times. Yeah. How about we just do this? We use a tab character and we just make a buffer. Yeah, we can just make can you simplify this? It will be 2 spaces times n. Okay. Oops. So that's a create ident. And then here, where are we here? This create ident, indent. These are all children of that? Really? I guess so. Well, I mean, that's the task right there, right? Oh, it works. That was quite the task. Let's see if they have a solution to this 12 too. Let's go here, chapter 12, 1. They have a solution for 12.1. But we've already done that one. Well, let's look at the solutions. 12.1. Huh. Here it is, solution. And then 12.1 zig. I did mine in zig. Made it a little bit more complicated. So did it open dir, there's open dir here. They use read dir. We just use the iterator. So here are your numeric. Where are the C things here? Oh, username from. Yeah. There's an is digit that I could use, but I wrote one. Use fopen, status. Oh, you use fgets. That's a good idea. Yep. Cool. I'm gonna run val grind. Val grind. Yeah, I want this tool. Oops. Tool hell grind. Val grind tool. Hell. Was it tool? Tool equals hell grind. Okay, val grind. Tool equals hell grind. Build 12.2. What if I run it like that? So I can run it, but I can't run it under Valgrind because a function redirection, which is mandatory for this platform tool combination, can't be set up. Details of the redirection are here. A must be redirected function whose name matches the pattern mem copy in an object with so name matching so was not found while it's processing symbols in the object. Install glibc's debug info package on this machine. Ask the packagers for your Linux distribution to please in the future ship a non-stripped LD-SO or whatever the dynamic linker SO is called that exports the above named function using the standard calling conventions for this platform. The package you need to install how do I get this working on ours? No. Let's try 0. Oh, maybe because I'm using Zig now. It's like GCC. Let's try that. I was able to run Valgrind on other things earlier.
Okay, just giving up on this. Alright, there is a third exercise here. Write a program that lists all processes that have a particular file path name open. This can be achieved by inspecting the contents of all the procpid fd star symbolic links. This will require nested loops employing redir to scan all the procpid directories, then all the contents of procpid fd entries within each procpid directory. To read the contents of a procpid fd and symbolic link requires the use of read link. Yeah. For this one, I'm going to weird. Why did that glitch out? Oh, because I crashed the, yeah. Let's go to 12. Here we go. Zoom in a little bit here. Oh, accessing. Um,
W random. Okay. Try that one. Hey, look at that. Alright. I'll keep Gemini open. I kind of like Gemini more than ChatGPT. Let's go ahead and commit all this stuff. Then README, we'll mark chapter 12 as done. Oops. Chapter 13 is going to be file IO buffering. File IO buffering. MKDR chapter 13. Get status, get at all, or let's cd into chapter 12, make clean. Actually, ls and then while read line to echo $line done. Here we're going to say do if d $line, then echo $line vi done, and then here we're going to say cd into dollar or push d to $line, run make clean, and pop d. Status, get at all, get status again. Oh, we got a zig cache now. We gotta go to chapter 12. Remove the zig cache. Get ignore zig cache. What was it called again? Zig hyphen cache. And then we gotta remove these. restore stage. Get restore stage dot zig cache. Can we also do like zig clean? Grep cache 2 1. What is this VG core? Is that a core dump? I want that shit there. That's a Valgrind core dump. Okay, get ignore, zig cc, makefile zig, bunch of ref lib ch. Uname zig. Alright, looks good. Give me 1 second here, just need to input my password. Alrighty. There we go. Alright. Is almost 7, chapter 13. I need to get food. So I'm gonna break for the evening. I gotta go grocery shopping, eat dinner. So I will be back tomorrow, starting in chapter 13, file IO buffering, standard IO library, controlling the kernel buffering of file IO. Advising the kernel about IO patterns, bypassing the buffer cache, mixing library functions and system calls for file IO, summary, and then file systems, chapter 14, disks and partitions. This is gonna be a little dated. Mounting, lots on mounting.
Okay. So tomorrow, file IO buffering and file systems. Let's load up our task manager. Chapter 12, T7, done. So I'm 18% up. This is gonna be a long journey. I don't know if you can see how big this book is, but the right hand side is how much I've done so far. It's such a brutal book. This exercise really slowed me down. I think it was good in that it led me to look for implementations of hash maps and dynamically sized array lists. And I found one that was really nice. It's just a header file and you control with like macro pound defines instead of like having to dynamically link against something like glib. But yeah, I like that I had the opportunity to go in and like experience that a little bit, because normally I never mess with that sort of thing. And I found this one. It's STB lib. It's actually nothings. What is under nothings? Sean Barrett. STB. Set-top box? No. Oh, Sean T. Barrett. That makes sense. STB. Popularized C header file libs with STB. It smells like if celery was mad at you. Okay. How many, so almost 2,000 lines. It's a lot of code. Oh, it has unit tests, that's why. Well, no, this is just a few, maybe 100 lines there. I'm not going to look into the implementation of this, but yeah, I was glad to have found this. So I guess doing the exercise did kind of push me to finding these data structures. I didn't really do a good job on the exercise and cleaning up my memory because I was just like kind of rushing through it. I allocated a bunch of memory that I didn't clean up, but it's a short-lived process, so it cleans up its own memory when it exits, so I'm not too worried about it. Wanted to run Valgrind on it, but Valgrind did not like that binary for whatever reason. So I guess lessons learned for today is that if I want to get through this quickly, I can't do the exercises, but the exercises do bring experience. I feel like I learn a little bit, or a lot, actually, a lot more if I do the exercises, but it's gonna take me forever to get through the exercises. So it's like I have to be judicious in like how I use my time here. Realistically, I'm never gonna use these like C primitives for anything. Like I don't do any coding where like C would be a good fit. I feel like C is kind of at this point not a great choice for really anything. Just because there's languages like Rust and Zig and other languages like Odin that are more modern and have all this stuff built in. Like they have all these data structures built in. So yeah, spending a lot of time writing C code doesn't seem like a good use of my time. But I don't know. I'm on the fence. I think I needed to be a little bit more judicious about how, like, which exercises I do and which ones I don't. This one was an involved one. It took a little while longer than I would thought. Like implementing something like this algorithm I thought of with hash maps and dynamically sized arrays in a language like Go or Python or anything that has garbage collected memory, and it has these data structures built in, would have been like a super easy problem. But because C, like even with strings, you have to like set up buffers and stuff to parse things into. It's just like, oh, Jesus. So yeah, I think moving forward I need to be a little more judicious in how I use my time on the exercises. Let's look forward in this chapter 13. Yeah, so there's like 5 exercises on this stuff. Like when the exercises are like simple in like a few minutes, maybe I don't have a problem with it. But when it's like write a program and has all these requirements and you have to do all this low level stuff, it's like maybe that's something I can just offload to like Gemini to do for me. Yeah. All right. I'll be on tomorrow after the gym to resume work on this and start on chapter 13. Cool. All right. Bye.